Chapter 9, Section 1 for Algebra. Something you probably have never worked with before. I don't believe it was even introduced to you yet. Quadratic functions. Seems like a big word, but that doesn't mean it's more difficult. It just means that it's not linear. We've been working with y equals mx plus b and lines all of algebra, but now it's quadratic functions. A quadratic function looks like this, not horribly complicated. Y equals, just like y equals mx plus b started with a graph, but then it's ax squared plus bx plus c. So what really got added to this is the ax squared. I mean, compared to mx plus b, like roughly that would be linear. This is quadratic. Y equals ax squared plus bx plus c. So there would be a number for a number for b, and a number for c. That's a quadratic function. What does it look like? It's something called a parabola. Write that down. Maybe even try to say it out loud. Parabola. Dun, 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 dun. Parabola. Dun, 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 dun. Parabola. And a parabola, if it's just y equals x squared, there's no bx, there's no c. It's just the basic, most simple, easiest graph you could possibly graph, y equals x squared. It looks like this. Notice it hits right here at 0, 0, and it goes perfectly up at the exact same rate on the right side of 0, 0 as it does on the left side. And how do you get it to make that perfect little curve? Well, it makes sense that if we plug in the number 1, what is 1 squared? 1 squared is 1. If we plug in the number 2, what is 2 squared? 2 squared for your y value will be 4. If you plug in the number 3, 3 squared is 9. And why does it go up the same the other way? Because if you plug in the number -1 in parentheses, if you're using a calculator, a -1 times a -1 is a +1. A -2 times a +2 is a +4. A -3 times a -3 is a +9. So when you go left 1, it's up 1. Left 2 is up 4. Left 3 is up 9, which is why you have the exact same curve on the right side of 0 as you do on the left side of 0. It makes that shape for you. A couple other parts of a parabola are the vertex. The vertex in this specific case is at 0, 0. You always write the vertex as a point. Your vertex will be always written as x first and then y. But again, it's not always at 0, 0. It could be, I guess I can't move that, but if I moved my parabola, it could be over here. Well, now your vertex is at 1, 2, 3, -4, 2. So depending on where that point is, the very bottom or the very top of your graph, that's where your vertex is. X first, then y with parentheses. And if it's not answered with parentheses and the comma, it is a wrong answer. And then we have this purple line going right through your parabola, cuts it right in half, splits it right down the middle. It's called an axis. Now think of this word axis, just like on the Earth. If I had an Earth has an axis that goes right through it. Whoops, I drew it. Probably should have gone from North Pole to South Pole. I was trying to tilt it on its axis, but then the whole Earth would have happened. But it splits it right in half. So again, called the axis, makes sense, of symmetry. And symmetry basically means the same on one half as it is on the other half. Axis of symmetry. If I cut this in half, I'd have two halves that are exactly the same, or better yet, if I folded it right on the axis of symmetry, it would fold this half of the parabola right onto the other half. So the green dot is called the vertex, the red curve is called the parabola, the purple line is called the axis of symmetry. Always dotted for the purple line. Always dotted line to go through the middle because it's not actually part of the graph, it's imaginary. If it's not actually there, you draw it that way. Axis of symmetry, the definition of it is that it will always pass through the vertex. It passes through the vertex and is a vertical line. It'll always go straight up and down right through the parabola. Perfectly vertical, up and down. Has to hit the vertex, which means your equation will always be x equals something. And that x equals something will always be the exact same number that your vertex is. So in this case, it's x equals 0 because it's going to go through right at the x value of 0. And then remember, that's an equation of a vertical line. We did vertical and horizontal lines way back in first semester. But that is a vertical line at x equals 0. Means every single point where x is 0 makes a line. Y changes, but x doesn't. So let's practice those. If we have this diagram, which if you don't have a handout, you're going to have to draw it quick. Just make a quick little graph. At least put these markings on it. You don't necessarily have to draw the whole grid, but put 5 of those and 5 of these up. Where is the vertex? Right here at the very bottom of the parabola where it changes directions. Always gets written as a point. And in this case, it's x, 1, 2, y, 0, because it didn't move up and it didn't move down. Axis of symmetry is the equation of a line. Always starts with x equals, and your axis of symmetry has to go through the vertex, so it'll always be the same number as there. And if you need to draw it, you go over to, draw a dotted line. Axis of symmetry splits it right in half. Let's try the second one. Pause it if you need to draw it on there. Okay, come back from your pausing. The vertex this time is right here where it changes direction. Go over 1, 2, 3. Over 3, up 1 space. Over 3, up 1, x comma y. Where is the axis of symmetry? It's at x equals, and it's got to be the same value as the vertex because it's going to go through the vertex. X equals 3. Right through the middle. Try this one on your own. Yes, the parabola is, you would say, upside down. Mathematicians would say the parabola has been reflected. So find your vertex, find your axis of symmetry. Pause it and come back. All right, you're back. Vertex is still the point where it changes direction. Now it's at the top of your parabola instead of the bottom. You went left 1, up 2. Axis of symmetry, x equals -1. Okay, but that's not all your lesson is about. We're also going to, besides, technically that's really just vocabulary. Now we're going to work on actually graphing these. Y equals x squared. And there's our good old friend, the t-chart. We've used the t-chart all through first semester with linear equations. You're going to use it again in Algebra 2 when you get a whole bunch of different kinds of graphs. You'll keep using a t-chart, so get used to it. I gave you the numbers this time. We always want to know what's happening at 0, what happens in the middle of the graph. But we can't only do positive numbers. We also have to know what's happening in the negative world. So if I put in -2 and square it, I'm going to get a +4. I'm going to ask you to be super careful as you use your calculators because calculators do order of operations. If you type in -2 and then your squared button, which is over here, that looks like -2 squared, but it's going to tell you it's -4. That's because calculators do order of operations. They do parentheses, exponents, then multiply and divide. Well, we don't have any parentheses, so it goes to the exponents right away, and it takes 2 squared. 2 squared is 4. Then it does multiplication, and multiplication is multiply it by a negative, so you end up with -4. So it's wrong, not because your calculator doesn't know what it's doing. You have to know how to properly type it in. Because order of operations will do parentheses first, we have to put -2 in parentheses and then square it. Or you could just know that anytime you square a negative, it comes out positive no matter what. So you could just type in 2 squared or 1 squared. But using the parentheses is a good idea. 0 squared is 0, 1 squared is 1, 2 squared is 4. We graph those on a graph, just like if it was a coordinate pair at -2, 4, -2, 4. -1, 1, 0, 0, 1, 1, and 2, 4. Now, this is not an elementary connect the dots assignment. We're not going to go doot, 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 and see what we make. It's not jagged. It's not sharp. We are not connecting the dots. We're trying to send a curve through it, and the curve is going to go up and around and extend. Okay, so I missed a little bit, but I can move it over. Try to curve it and make it look like a parabola. That's our parent graph. We'll call that the parent. That's the one that we're going to compare everything to because nothing happened to our x squared. It's not multiplied by anything. It's not added to anything. But let's see what happens when we have y equals 3x squared. It's going to look close. It's going to look a little different. Use your -2 as your x, but this time you're going to type in 3 times -2 in parentheses squared because it's 3x squared. So if I go 3 times -2 squared, it equals 12. Makes sense. 2 times 2 is 4. 4 times 3 is 12. So 12. When I take 3 times -1 squared, I get 3. 3 times 0 squared is 0. 3 times 1 squared is 3. 3 times 2 squared is 12. So what does that look like on here now? Now we're going -2 up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It is off the charts. But as long as we have 3 points that fit on the graph, that should be enough to make a curve. So left 1 up 3, 0, 0, right 1 up 3, and right 2 up 12. What happened to our graph when we multiplied it by 3? It didn't really move as far as where it started, but look at it. It is super skinny. If you compare that to how our y equals x squared looked, when you multiply it by 3, it makes sense. You multiply. Multiply means bigger. It took your graph and it made it taller. Well, what happens when something gets taller? It kind of shrinks. It kind of gets skinnier. Okay, so multiplying by 3 is going to take that graph and stretch it out 3 times bigger than what it was. This was supposed to be at 1. What's 1 times 3? 1, 2, 3. This was supposed to be at 4. What's 4 times 3? 12. The one that was supposed to be at 9 would end up way the heck at 27. So multiplying by 3, if you compare it to y equals x squared, it is taller. 3 times taller than it would normally be. Let's try another one. I know these notes are getting a little bit long, but you've got to be able to graph. Sorry, there's a hiccup. Y equals x squared plus 5. So now we're taking our -2 squared in parentheses and adding 5 to it. -2 squared plus 5 is 9. -1 squared plus 5 is 6. 0 plus 5 is actually 5. Be careful on that. 0 plus 5 is 0. 0 plus 1 squared is 1. And 0 plus, well, what am I doing? Back up. 1 squared plus 5 is 6. And 2 squared plus 5 is 9. So my point now is -2, 9. 6, 7, 8, 9. I better erase those other points or I might use them. -1, 6. 6. 0, 5. 1, 6. And 2, 9. Draw a nice smooth curve to the best of your ability. There's a parabola. We want to compare that to y equals x squared. How does it look compared to y equals x squared? This is y equals x squared. Some might say, it definitely looks skinnier. Is it skinnier? Or did we just take the exact same parabola and move it up 1, 2, 3, 4, 5? It's the exact same size. Nothing happened to it when you added 5 to it. Other than, if you compare it to y equals x squared, it moved up 5 spaces. And how do we know that? Because it said plus 5. Up 5. So addition is different than the multiplication that we did when it got 3 times taller. So we know what happens when we multiply. We know what happens when we add. Let's see what happens when we make it a negative. This says we want the opposite of x squared. Well, if we know negative 2 squared already is 4, we want the opposite of that, negative 4. If you really want to type it in your calculator and do the work, it has to look like this. The opposite of parentheses, negative 2 squared. What's the opposite of negative 1 squared? It's negative 1. The opposite of 0, don't put a negative 0 in there. Look at my face, it's all full of graphs. Don't put a negative 0. There's no such thing as a negative 0, it's just 0. What's the opposite of 1 squared? It's negative 1. The opposite of 2 squared is negative 4. Do the math, do the graph, x comma y, left 2, down 4. Left 1, down 1, 0, 0, right 1, down 1, and right 2, down 4. Exact same parabola as y equals x squared, except that negative caused it to go upside down. I'm going to call it reflected down instead of upside down. It reflected down. How do we compare it? The vertex is in the exact same spot, but it took this graph and it went whoop and flipped it. We have 2 left. We know what happened when we multiplied it by 3. Now what happens when we multiply it by a quarter, or which is kind of the same as dividing by 4, and it's negative. Right now you should already know that this graph is going to be upside down. It's going to be reflected because it's negative. But what's going to happen to it with the 1/4? Look at my numbers I changed over here. We should get good at that. And that again is coming back from first semester. If we have a fraction, you have to use numbers that will divide by that fraction if you want to make whole numbers. So I want the opposite of 1/4 times negative 4 squared. Type that in. What's the negative of 1/4 times negative 4 squared? You get a negative 4. What's the opposite of 1/4 times negative 2 in parentheses squared? You get negative 1. If you take all of that times 0, you still get 0. The opposite of 1/4 times positive 2 squared, you guessed it, is still negative 1. And the opposite of 1/4 of positive 4 squared still comes out to a negative 4. So my graph is now going to go down 4, or left 4, down 4. Left 2, down 1, 0, 0, 2, 1, 4, negative 4. What did that graph do compared to the original parabola? Here's our parent, y equals x squared. Not only did it flip it and reflect it, see if it'll let me flip it. Might not, but it might. Let me try it. Not only did it reflect it, but it also made it, try to visualize this, shorter. It shortened my parabola. Makes sense because it divided it by 4. It took the size of it and it divided it by 4. This point was supposed to be at 4. When you take 4 divided by 4, it goes down to 1, or -1 in this case. What happens when you make a graph shorter? It looks fatter, it looks wider. But how do we compare it to y equals x squared? It is a shorter graph. And of course, the negative made it upside down, as you'd say. Last one, and maybe you can predict this. You're going to subtract instead of add. When we added 5, it went up 5. When we subtract 2, guess what? It's going to go down 2. You can pause it so you can take the time to write this down. But we're going to get 2 here. Oops, -1 minus 2, -1, -2, -1, and 2. What does that look like? Left 2, up 2. Left 1, down 1. 0, down 2. 1, down 1, and over 2, up 2. Always make sure once you are done graphing that this actually looks like a parabola. Otherwise, you made a mistake. Those dots should be on the same side, opposite side of the vertex. How does that compare to our original graph? It's the exact same size. The only thing that it did is that it went down 2 spaces. Down 2 spaces. All right, so here's the parent graph. When you multiply it, it gets taller. You may want to put that in there. Taller, of course, makes it look skinnier. When you add, it moves up. When you make it the opposite, it reflects. When you either divide or multiply it by a smaller number, a number smaller than 1, whether you take a pizza and cut it in fourths or divide it by 4, it's the same thing. 1/4 of the pizza is the same as dividing it by 4. What does that do? It makes it shorter. And if you subtract, it moves it down. So you've got to be able to graph, and you have to know your vocab. Good luck.